Alright, we'll continue on with Chapter 8. This is an extension of multiplying polynomials, which we learned in the last section. And this one is for special products. So these are multiplying polynomials, but only for polynomials that meet a special condition. So there's 3 different ones that we'll look at. These are all formulas which you don't have to memorize because the old method of multiplying polynomials always works, but it's a shortcut and it will save you time, and they come up frequently. So you're highly recommended to try to memorize these. The first one is a perfect square. A perfect square is anything in parentheses squared. Now, if the thing in parentheses is a binomial, then the way that you would write it out would be a plus b, and then when you square something, you multiply it by itself, so you write a plus b again. So if you apply FOIL or the rectangle diagrams or distribution to this product, a plus b times a plus b, so the first term is a times a, which is a squared. The outside is a times b, the inside is b times a, but a times b and b times a are actually the same thing. So when you combine them together, you get 2ab, and then the last times the last is b squared, which is b squared. Now, the reason this is important to highlight and emphasize, even though it might seem simple at first, is you learned an exponent rule that says you can distribute an exponent into a monomial. Now, this is a binomial, but even though logically you know you're not allowed to do this, you'll be very tempted to distribute the exponent in, and you have to caution yourself not to do that. This is a binomial squared, so you have to write it out or memorize this shortcut. So if you just distribute the exponent in, you'll get the a squared and you'll get the b squared, but you'll completely miss this middle term, often called a cross term, of 2ab. Likewise, for a perfect square that's a difference or subtraction, it's essentially the exact same formula, but the middle term is negative instead of positive. Okay, the last term is still positive because a negative b times a negative b is a positive b squared. So this one you need to memorize as well. And then the third special product is called a sum times a difference, or product of a sum and a difference. So in the first one you have a plus b, in the second one you have a minus b. Now here's something really cool happens. The first times the first is a squared, which is right here. And the last times the last is negative times a positive is negative, and then b times b is negative b squared. But what happened to the two terms in the middle? Well, in this case, the outside one's a negative ab, and the inside one is a positive ab, and these two cancel out. So the one that might seem like it would have the stuff in the middle is the one that cancels out, and the two that might seem like there's nothing there are the ones that actually have stuff there. So these are 3 special products. Remember that you can always solve them by writing them out and using FOIL or distribution. So problem solving tips, they're not new, they're just a result of something you've already learned. As I said before, avoid distributing the exponents for perfect squares. Instead, either write them out like this as a product of 2 binomials, or learn and memorize those shortcuts. And then note that in these formulas, in these 3 formulas, a and b are just placeholders. They could stand for any variable or any number or any combination of variables and numbers, and you can still apply the same theory. So let's do a couple of examples so you can see this in action. Okay, first one, find each special product. This is a perfect square and it's a sum, so the formula is the first thing. So if this was a plus b squared, right? The first thing is a squared, but in this case it's an n, so I write n squared. Then I have plus 2ab. So I have plus 2 times a, which is the first thing, times b, which is the second thing. So 2 times n times 3 is 6n, and then plus the last thing is b squared. So I have 3 squared, which is 9. So very easy. Let's try the next one. This is a difference. So I have y squared minus 2ab, so 2 times y times 7 is 14y plus 49. Be careful, the last term is positive because it's a negative 7 squared. A negative number times a negative number is always positive. Okay, how about here? This is a special product. It's a sum times a difference. So it's the first thing times the first thing, b squared, minus that times that, which is 1. The middle term, positive b here, and negative b here, perfectly cancels out. And here's a perfect square as well, a perfect square of a difference. Now, if you forgot, you could always write it out as p minus 4 multiplied by p minus 4. Or you could memorize this formula here, a squared plus or minus 2ab plus b squared. So p is the front, p squared, minus 2ab. So multiply this by 2, and then multiply by p. So minus 8p, because 4 times 2 is 8, plus this number squared, plus 16. Okay, so this is how you do these kind of problems. The keys to remember are, if you have a perfect square, either use the formula or write it out, and then just follow those patterns. And if you forget anything else, you can always write it out and go the long way with FOIL or rectangle diagram or distribution. That's it for this section. We'll see you next time.